So let us start with our last unit. First part of this will be the disk scheduling and then the I/O management. So let us start with the disk management part. The objectives is basically to see different ways of storing the data on secondary storage device, the physical structure of disk, what are different performance characteristics of mass storage device. The most important part is disk scheduling algorithms and some introduction about RAID. Okay, that is redundant array of independent disk. Let us start our discussions of disk management. Now we gone through the memory management, that is the primary memory, and the secondary memory is typically called as the disk. So the secondary storage that is required for a bulk amount of space. This is non-volatile and magnetic disks are used for that. Typically they are of very less speed as compared to your processor and even memory. We already gone through the hierarchy, wherein we know that the fastest one is the CPU registers. Then we have cache, then memory, and then the secondary storage part. Now again, so many technologies are also there for the secondary, that is mass storage. Now the reading and writing style with the magnetic disk is with read and write head. Anyways, that we'll see, wherein we know that there is something called as a read-write arm is there, and different read-write heads are there, and your hard disk is actually divided in sectors and tracks, and multiple cylinders could be possible. And the drive actually rotates 60 to 250 times per second. Now that is for magnetic disks. Though it provides bulk storage space, comparatively its speed is very less. Now we have hard disks with more speed, something like 5,400 rotations per minute. Yeah, typically calculated in RPM, like 70 to 100, that is 7.2K. Okay, so that is one more common speed of disks coming with desktops. Laptops, it is from 5400, then 7200, then it's around something like 10K, and typically with server, whenever we have SAS controllers, it goes up to 15K. Okay, so the transfer rate is the rate at which data flow between drive and computer. Maybe most of the time it is the buffers. So that is part of your primary memory, right? In addition to this transfer rate, we need to think of seek time also, because though it provides bulk space for storage, if the file is distributed at different locations, then we need to think of seek time also. Seek time is like the time required to move disk arms to the desired cylinder. So that is what the seek time is there. And in addition to that, also the time required for desired sector to rotate under the disk head. That is the rotational latency. Maybe in the next slide you will come to know how exactly the mechanism or moving head of disk is there. The important part is whenever the moving head makes contact with the disk surface, that creates a problem. The head of read-write head will crash. Disks can be removable also. If you are aware of something like hot swappable disks, the typical word used for that is hot swappable. Like if you visit our server room, whatever the servers we have, they usually have like 4 or 8 hot swappable disks. So even though your operating system is running, you can literally just press one button there and remove the hard disk. Even you can insert newer one. So disks can be also removable. Okay. The reason behind that is whatever the required thing. See, very important part is processor don't know anything about your disk, because processor do not read disk content directly. Those contents has to be fetched into the main memory, maybe by supporting cheats or maybe direct memory access kind of mechanisms. Different utilities are available for that. Okay, and once that reading or writing is finished, typically that supporting mechanism like DMA will send some sort of interrupt to your operating system, and then data will be available maybe in the buffer, and then the processor will read it. Okay, different channels are used to connect these hard disks to your motherboard. I can say something like ATA is there, SATA is there, even fiber channels are available, SCSI, SAS. So many different kind of host controllers or disk controllers are also available there. Now in this diagram you can see a typical moving head mechanism for disk, where we have something called as ARM assembly, to which the read-write head is available. Okay, multiple platters are there, and now if you think of a single cylinder, it is divided into tracks and sectors, and for every cylinder there will be read-write head. Okay, so have a look at the sector and track. You can imagine like track as your running track on ground. It's exactly like that, and now the tracks are further divided into small sectors, and then collection of sector, maybe you go with some sort of partition, and then you format that partition with some sort of file system, right? And file system is a data structure which is now talking with operating system to manage the data on hard disk. Okay, so this is the typical mechanism for moving head, right? Now hard disks, multiple registers are there in terms of storage, in terms of the speed of spindle in RPM. So for example, if you see the table here, let me highlight it. If you see the table, for example, 54007200, these are more common in laptops. Even earlier 4200 spindle speed. If you think of something like desktops, it's something like 7200 up to 10K, and with server SAS controllers, 15K speed is also possible, where latency is reduced. You can check it here. So it is coming down from 7.14 to 2 milliseconds. Okay. The theoretical transfer rate of hard disk is 6 GB per second. Effectively, 1 GB per second data can be transferred. Anyways, it all again depends from where to where you are transferring this data. So for example, you are copying something from hard disk to your pen drive. Then it is not just speed of hard disk that matters, but it is also the speed of USB port, like USB 2.0 or 3.0 or 3.1. So it all again depends. The speed is typically, the maximum is given by the lowest lead, something like that. Okay. So seek time, yes, I already mentioned that. The latency that is calculated based on spindle speed, that is given in this table. It is 1 divided by RPM divided by 60. Okay, so that is how. So average latency is again calculated by calculated latency divided by 2. Now, talking in terms of performance of hard disk, the access latency is given by average seek time plus average latency. So for fastest disk, it is 3 millisecond plus 2 millisecond. So 3 millisecond is average seek time and 2 millisecond is average latency. Now try to understand the difference between both. The seek time I already mentioned. It is the time required to move disk arm to desired cylinder. Okay. So that disk arm has to be positioned over desired cylinder. That is the seek time. And the time for desired sector to rotate under the disk head, that is the average latency. Okay. So that is given like from previous table. So 3 millisecond is average seek time and average latency. So for fastest it was 2 millisecond. If I go back to the previous slide, just refer this. So for fastest it is 2. Got it? And for slow disk it is 14.56 milliseconds. These are just a few calculations, because mainly whenever you are dealing with some sort of data transfer between hard disk, the latency is just mostly because of hard disk, and for that we need to select the proper disk scheduling algorithms. Now you can see this image. One of the hard disk by IBM. Capacity was 5M characters. You can imagine like 5 MB just. Nowadays we have a very small chips, even with terabytes of storage. Now after hard disk, nowadays we have something called as SSDs, solid state disks, right? So now they are even called as a non-volatile memory, used like hard drive. Like memory, just reason is there is nothing like moving spindle, moving head, moving arm is not there. Okay, that can be used like memory, but it's non-volatile. So there are so many technology variations available that typically it is said like your normal hard disk compared with the solid state drives or SSDs, the speed is around 15 to 18 times I'm saying 15 to 18 times more than your HDDs, hard disk drives. Okay. Anyways, because of this speed, usually, the comparison of the cost, the capacity, and speed. Like whenever you get more capacity, speed is less. So in case of SSDs, they are more expensive. Capacity is less, but they are much more faster. Okay. And because there are no moving parts, there is nothing like seek time or rotational latency. So they are actually much faster. Now even nowadays, if you see SSDs, there is something called as NVMe, not just SSD nowadays, but NVMe SSDs. Let me type in here. NVMe, which actually stands for non-volatile memory express. Now, if you see the speed of NVMe, I think this is the latest technology available as an storage secondary memory, NVMe SSD. Okay, like as I mentioned, SSD is 15 to 18 times faster than HDD. NVMe is again more faster than SSD. It is at least 5 times faster than your normal SSD. Okay. Magnetic tape typically used for backup, rather I can say. They are very slow access time, and they are not used for live computations with your any program. They are typically designed for backups. Their life is larger, and even they have larger storage also. Whenever very infrequent use data needs to be stored, mostly as a backup of different applications, that time these magnetic tapes are used. They're very less speed. Like for example, as I mentioned, for hard disk it is 1 GB per second. It is around 140 MB per second. This one, 140 MB per second. Okay. Now, this structure, if you see, the disk drives are usually addressed as a one-dimensional array of logical blocks, and they are formatted at a low level, where sector 0 is the first sector of first track, and that will be at the outermost cylinder. So let me share the whiteboard. So it is something like this. Okay, now let me select another color here. So blue will be one track. Then I'm selecting this yellow color. Maybe this will be another track. something like this. One more track. And now this will be divided something like this. Okay. So this sector 0 of the first track, counting starts from outermost cylinder. Okay. Now there is something called as a bad sectors. If there is a storage problem, okay, few can be marked as a bad sectors where data cannot be stored. So that is what happens at very low level. Attachments. Now how disks are attached to your host. For that, definitely what we need is I/O ports talking to different I/O buses. But the most common is SCSI. Anybody know the long form of SCSI? Yes. Okay. SCSI is basically a small computer system interface. That is a set of standard for connecting some sort of devices or peripherals to the computer. Small computer system interface. If you look at the different evolutions now in terms of again the mainframes, then mini computers, then we travel to handheld devices also. Okay, but if you go somewhere with your personal computers, for these small computers, this is one of the standard interface, right? Which gives you set of standards for physically connecting and transferring data between computers and different peripheral devices. So for computer, your hard disk is also a kind of peripheral. No? Now, this SCSI is actually kind of a bus to which you can connect up to 16 devices. Normal, if you have a normal, say, desktop, and imagine like you have, like even IDE connectors are there, SCSI connectors are there, SATA connectors are there, different variety of connectors are available there. And with this SCSI, we can target up to 8 logical units that can be connected, and the device, this can be attached to different device controls. For this, we can have high-speed serial architecture, and even we can make use of some sort of storage area networks, typically known as the SAN. And there is one more terminology used called as a NAS, Network Attached Storage. NAS box for simple for that. So let us move to next. We can have something called as different storage arrays, where we can attach multiple disks. There are ports to connect host to array. We need some sort of additional memory. Just a minute. To this array, we can actually connect so much of space. Now you simply try to compare it with number of disks you can connect to your personal computer and number of disks typically connected with data center. Okay. Two things. There is something called as a hot spare, hot swap, and RAID. Now I just would like to talk about RAID. RAID stands for redundant array of independent disks. Okay, let me share the whiteboard again. So let us see what is RAID first of all and different RAID levels. So suppose this is one hard disk. Okay, different cylinders are there, sectors, tracks, everything is there. And now this is connected to your say desktop, and you have your important data on it. Now typically we divide this hard disk into multiple partitions. Say for example, we have three partitions, C, D, and E. Three partitions are there. Okay. Now what will happen if there is problem? Anyway, this is electronic component, right? This is electronic device kind of a thing. Now, if there is problem with this hard disk, you definitely lost everything, right? Then suppose we have another, let me use a different color for that. Now suppose this is disk 1 and this is disk 2. Assume this is 1 terabyte and this is 1 terabyte. 1 terabyte plus 1 terabyte, right? Now my very simple question is, can we create one partition of size 1.5 terabyte? In normal situation, answer to this question is no. We cannot create a partition of size 1.5 terabyte even though we have 2 terabytes like 2 disks. Because while creating partition, we need to select the hard disk and you can select only one hard disk. Okay. Now, just I would like to talk about RAID, redundant array of independent disks. Let me delete it. I just want to use RAID. Okay, because it is given by different RAID levels also. Okay. Now I would like to answer 2-3 questions. What are different RAID levels and how we can utilize this to create the partitions of size 1.5. Okay. So very first and most important thing is, for safety purpose, for recovering data, whatever data we write here on disk 1, the same data will be written here. Okay, so this is one of the RAID level and this is called as mirroring. This is called as mirroring. Okay. So that is basically for or this is called as a disk stripping. Do you know what is advantage of this? So suppose you want to store some sort of a data. Suppose you have one file of size 100 MB. Okay, maybe 50 MB will be stored here and 50 MB will be stored somewhere here. This is called as RAID 0. RAID 0. That is the stripping. What do you think? What is advantage of this? Stripping. See, there is advantage also, there is disadvantage also. Okay. Prevention of data loss. No. Prevention of data loss is not provided by RAID 0. There is no fault tolerance because there is no redundancy. Only advantage is, as I mentioned, the speed of read and write will just get double, because for this hard disk we have a separate read write head. For this hard disk we have a separate read write head. So whenever you want to write the data or whenever you want to read the data, simultaneously both the arms will busy in reading data. So for example, I don't need to read 100 MB. It will read 50 MB from one disk, 50 MB from other disk. So advantage of RAID 0, that is the stripping. This is called as the stripping. Advantage of this is the speed. Actually, what we do is we'll spread the data. Okay. Whereas if you want kind of a fault tolerance, only solution for that is redundancy. I think I started with something like, whenever you want to store data, let me select. Okay, so something like 100 MB of data will be divided and it's not exactly 50 MB. That will be decided actually by block size. Yes. So this is called as RAID 0, that is stripping. So 100 MB data is there, but it is spread across two disks. Maybe first 50 MB will be stored on first disk, next 50 MB will be stored on next disk. This is called as a stripping. Advantage I just mentioned is read write speed, but disadvantage is if either of the disk failed, entire data fails. Because actually data is spread. Okay, this is called as a RAID 0. Now next one is called as RAID 1, and that is called as mirroring. RAID 1, mirroring. Now what happens with mirroring is, whatever your 100 MB data is there, the 100 MB data will be stored in disk 1 and the same data will be stored on other disk. Same. Meaning of this is again the same thing, 1 terabyte plus 1 terabyte, even though 2 terabyte of space is available, actually we are getting just 1 terabyte because same data is replicated on other. Advantage of this is fault tolerance because there is a redundancy. So if either of the disk fails, we can recover the data. But then the disadvantage of this approach is speed. Because whenever you want to write 100 MB, we need to write it twice. Whenever you want to update the data, updations must be done at 2 different copies. Okay, so that is disadvantage. Now there is something called as other RAID levels also. So for example, there is something called as a RAID 5, which is more popular. Okay, and what happens with RAID 5 is, even RAID 10 is also there. RAID 5, this is typically called as parity. The name is something called as a parity. Okay, wherein what happens is for RAID 5, at least 3 hard disks are required. So for example, let me take one more thing. So at least 3 hard disks are required. Okay, and data is divided in such a way that it will take advantage of both the stripping also and the mirroring also. Data is distributed in such a way that if any one of the hard disk is failed, still there is no problem with your data. Data can be recovered. Fault tolerance is provided. So that is the main thing behind this RAID 5, which is most of the time popular in case of what I can say, servers. So if any one of the disks fail, you simply remove that disk, add a new hard disk there, automatically it will recover the data. So that is the RAID 5. Similarly, there is something called as a RAID 6 also, where you can add one more parity disk. RAID 10 is also there, where you can support more than 2 failed hard disks. Okay. Anyways, we don't want to go in more details of this RAID, how it works, but at least you should know these 3 levels. RAID 0 is called as a stripping, RAID 1 is called as a mirroring, and RAID 5, it supports fault tolerance for one disk failure. See, mirroring also supports fault tolerance for one hard disk failure. Stripping, no, but it provides more speed. Parity, that is RAID 5, takes advantage of stripping and mirroring. So it will distribute data with parity. So somewhere parities are stored in such a way that we can recover data from one hard disk. Interestingly, if you say, for example, think of something like this is 1 terabyte of hard disk. Okay, this is 1 terabyte of hard disk, and this is 1 terabyte of hard disk. Now, in case of RAID 0, the effective storage will get is, I can say, 3 terabyte. Okay. In case of RAID 1, because data is replicated, exactly half capacity will be available for us. So 1.5 terabyte. And with RAID 5, which gives advantage of stripping and mirroring with one disk failure, will give up to 65% of total disk space. So I can say something like around 2 terabyte of. Okay. So those are different RAID levels. Now I was talking about now if I have 1 terabyte plus 1 terabyte, can I create a partition of 1.5 terabyte? For that, direct hard disks are not made available to your operating system. There is something called as LVM, logical volume managers. Logical volume managers. They can be utilized for this purpose. Okay. Now, whenever you have very big, say, think of something like the data center of Google, where normal desktops are not there. Okay, we have a separate data center, multiple servers are there, millions of clients are there. Maybe you have some sort of web contents also, and you now connected storage arrays where thousands of hard disks are there with multiple levels of RAIDs also. Even tape libraries also there for consistency or durability of data. And all these are connected through fiber channel for high-speed connectivity. Okay. Now that is what the SAN is. Only disadvantage of SAN is in order to implement this, lots of money you need to invest in that, and that is the reason nowadays. Now that money is already invested by some big bulls in IT sector, and now they are making it available to you as a cloud, like something like storage cloud kind of a thing. Like Google provides you something like say 15 GB of space with your Google account. Now, from where it is coming? Obviously, it is coming from your storage area network. Whereas if small organization is there, then we can implement something called as a network attached storage. Typically, that is used in LAN. So there is something called as a NAS box, and with NAS box, you can have multiple hard disks connected there, and you can share this with NFS or FTP, or even ISKG connection is also possible, where you can provide some sort of block device. A small organization can go with network attached storage. Right. Now, irrespective of whatever the secondary storage available with you, the important part is operating system is actually responsible for using your hardware efficiently. Now, if it is disk drive, that means we need to get the fast access time. And in order to get the fast access time, we are already aware that we should minimize the seek time. And seek time, as we already seen, it is positioning the head that directly depends on the distance, the seek distance. Bandwidth, this is the usual definition of a bandwidth, where it means disk bandwidth, which is nothing but the total number of bytes transferred divided by the total time between the first request for service and the completion of last transfer. So it is like a transfer rate. Now operating system need to select the disk scheduling algorithm very properly, so that it minimize the seek time. So many algorithms are there those algorithms anyways we'll see. For these algorithms, the important thing is something called as a request queue, where we'll think of the numbers, cylinder numbers rather. So for example, in this diagram, if you can check, for example, this is kind of a reference string what we have used in case of memory management. There we use the page numbers. Here we'll use it as a cylinder number. Considering that we have 0 to 199 cylinder numbers. That means total 200 cylinders are there. And now we need to access the hard disk, like first upon cylinder number 98, then cylinder number 183, then 37, 122, 14, so on and so forth. Last is 67. And currently the disk head pointer is at 53. Okay. So whenever multiple applications are trying to read the disk, okay, and each and every read-write request will be stored in the queue. For example, this is the situation of a queue wherein many applications, think of many processes. Like one process need to read cylinder number 98, one more is say something like 67, something like that. And currently my disk's head pointer is at 53. Now which request should be served first? That is what disk scheduling is. See, we have seen CPU scheduling. There are many processes ready to run. But then considering throughput in mind, we select the process for execution. That is done by the scheduler. Now here what we want to do is, we want to select the process in a such a way that we'll now consider disk scheduling part. Okay. Is this clear? What is this queue? Because this is required for all the algorithms. Hello. Sakshi, roll number B52. You just raise your hand. Would you like to talk something? Just unmute yourself and then continue. Okay. That was by mistake. No problem. I'll just lower it. Somebody is speaking. Just mute yourself. Who is this? Okay. So very first question I asked is, see, number of cylinders are 200. Number starts with 0, so 0 to 199 are the cylinder numbers, and there is a queue in order to access the disk. Now operating system has the responsibility to provide service, and for that, now which request is scheduled first? Obviously as usual, our first algorithm is first come, first serve. Okay. So for example, here you can see, now let me explain, because the answer is given very first, that is 640 cylinders, that is the head movement required. See, you imagine this is cylinder number 0 and this is cylinder number 199. Currently, disk head is somewhere here. Okay. The next request is 98. So from 53 up to 98. 53 up to 98. So that you can calculate it by simply subtracting 53 from 98. So 98 minus 53 gives you 45. So let me write it here. 45. Right. So moving from 53 up to 98. That gives me the movement of 45 cylinders. Now next in the queue, because the algorithm is first come first serve, the next is 183. So that gives me 183 minus 98 is equal to 85. 85. So now my head reaches here. Next is 37. So now from 183 up to 37. Here number of cylinders you need to cross is 183 minus 37, and that gives me 146. Are everybody getting it, no? So simple thing, simple subtraction I am doing. It is something like say 200 rooms are there, and suppose you need to provide some sort of service to different rooms. Currently you are at room number 53, and now you are supposed to move to, say for example, room number 98. How many rooms you need to cross? That is the way. Okay, so something like that. So from room number 183 to now room number 37. It is something, because this is as per first come first serve. Next after 37 is 122. So here is 122. So this can be again calculated by 122 minus 37. That gives me 85. So this movement is 85 cylinders. Now from 122 to 14. Here it is 14. So 122 minus 14, that gives me 108. So it is 108. Now from 14 to 124. 14 to 124. How much? 110, 110. Then from that to 65, that means 124 minus 65, total movement required are 59, 5 and 9. It is, let me, 5 and 9. and from 65 to 67. These are just two. Now what we need to do is we need to sum it all. So 45 plus 85 plus 146 plus 85 plus 108 plus 110 plus 59 plus 2. If you add all, it comes to 640 cylinders. Any doubt in this? Any doubt in this? Huh? Any doubt? Okay. I think it is already 11. So what I'll do is, tomorrow also at 10 we'll have a lecture. To save your time, because most of the internals are again scheduled, what I'll do is whatever the remaining algorithms are there, even after tomorrow's lecture. So tomorrow there will be lecture. Okay, and even after that, if anything is still remaining, what I'll do is I'll record the video and post it on Moodle page. Even whatever the remaining videos that recorded, that will be also posted. Okay, so now we'll stop here.